Almost every planetary ecosystem we know is driven by a single engine, a host star. The heat and radiation from a sun are the primary forces preventing a planet's surface from freezing. If a planet is removed from that light, physics suggests a predictable outcome. Without a constant influx of solar energy, the world should become a static, frozen sphere in the vacuum of space. Yet mapping the deep space between solar systems reveals billions of orphaned worlds wandering through the darkness. These planets have no host star, and they are far more common than astronomers once believed. The existence of these rogue planets forces a reconsideration of planetary survival. We have to look at how a celestial body can maintain its structure and temperature while drifting in total isolation. Meet Lyra. She is a rogue planet drifting light years from the nearest sun, visible only because she is silhouetted against the distant stars. On the surface, the conditions are lethal. The temperature is low enough to freeze methane into solid ice, creating massive blue caverns and oceans of frozen gas. But beneath the ice, there is a visual anomaly. A rhythmic blue glow pulses through the crystalline veins of the planet's crust, visible even in the absolute dark of the void. This light suggests an energy source hidden somewhere beneath the methane ice, a source that functions without any external input from a star. Lyra's journey didn't start in the void. Like Earth, she formed inside a traditional solar system, orbiting a star that provided a steady supply of heat. Young solar systems are often unstable. Massive gas giants and smaller rocky worlds frequently migrate, crowding the same orbital lanes as they settle into their final positions. This diagram shows the gravitational interference from overlapping orbits. Caught between massive gas giants, conflicting poles create a destabilized, chaotic path for the small planet. Acting as a slingshot, the planet gains velocity to break free, accelerating until thrown out entirely. This expulsion is a turning point. Without a star to provide heat, the planet must rely on its own internal mechanics to avoid becoming a completely inert block of ice. To find that energy source, we have to look past the frozen methane and travel miles beneath the surface. Deep inside the planet, the temperature is drastically different. A molten iron core remains white-hot, generating a constant flow of thermal energy. This cross-section illustrates radioactive decay. Unstable isotopes within the core break down, releasing intense heat that radiates outward through the mantle. This thermal energy forces its way up, opening geothermal vents that push steam into the frozen crust, melting the bottom layer of ice. This meltwater forms subsurface oceans. These liquid layers are trapped between the freezing surface and the burning vents, creating a stable environment of liquid water. The internal heat engine turns the planet into a self-contained sanctuary. It mimics the conditions necessary for life, operating independently of any external light source. Occasionally, Lyra's path brings her near an interstellar nebula. The frozen methane on her surface reflects the vibrant clouds of gas, turning the ice into a temporary mirror for the galaxy. For a brief period, the planet catches the light of an environment she left behind. The ice shimmers with colors that have no impact on the world beneath. The nebula provides beauty, but no survival. The planet continues her drift, powered by the permanent warmth generated in her interior, rather than the fleeting light of the stars. Astronomical models now classify these drifting worlds as self-contained systems, capable of preserving internal heat for billions of years. This suggests that biological ecosystems could exist in the dark, fueled by geology and chemical energy rather than photosynthesis. As Lyra moves past the nebula, she shrinks back into the darkness. She returns to the void, where the temperatures are near absolute zero. This transition changes nothing for the world below. The core continues to decay, the vents keep the oceans liquid, and the internal engine remains uninterrupted. Lyra's persistence demonstrates that a world can sustain itself indefinitely. Her survival is dictated by the thermal energy she has carried with her since the day she was cast out.